number 18. If so far, if we have x has a probability distribution function f of x equals 1/10 on 0 to 10, and then it's 0 otherwise, find the cumulative distribution function. So we're given the PDF here and being asked to find the CDF. Okay, so this is a uniform continuous distribution, and the idea is on between 0 and 10, this is going to turn on and be a certain height that gives it area 1. And then outside of 0 and 10, it's going to be off. So it's on here. And again, we want this to have area 1 here. So to do that, this has height 1/10. Okay, we want to find the cumulative distribution function. So again, in general, the cumulative distribution function, what it does is it tells you the area under the curve of everything less than some upper bound. So the cumulative distribution function, if you plug in an input, tells you the chance of having the random variable, with the chance of seeing an occurrence of the random variable being less than or equal to that x. So that is the integral from everything below x, so from minus infinity up to x, of your function. I'm going to change variables for a second just so I have a different parameter to work with. So you integrate everything, the chance of seeing all these inputs from negative infinity up to x. That gives you the area under the curve for everything to the left of x. Okay, so in our case, you want to evaluate this. So our function shuts off if it's less than 0. So between minus infinity to 0, it's just going to be 0. And so this term is going to drop out. And then the part that's interesting is going to be from 0 up to x. We're assuming x is going to be between 0 and 10. Otherwise, it doesn't do anything very interesting. Because if it's past 10, it's 1. If it's less than 0, it's 0. The CDF. And so in this zone, we have 1/10. Okay, so we know that one's 0, and so we need to just find the... wait, this is t. So we want to evaluate this. This is dt. Okay, so we have 1/10 t from 0 to x, so we plug this in. So we have 1/10 x minus 1/10 of 0. That drops, so we just have 1/10 x as our CDF function. So if we graph this, again, we know that from 0 and at 1, or 10, sorry for this one, we know that our function is going to be 0 here, and then 1 up there, and then in the middle, it's this formula here. Okay, and so this says that the CDF function is piecewise, so it's going to be 0 when x is less than 0 here, and then it switches to this formula when x is between 0 and 10, and then it is 1 when x is greater than 10.